Have you ever thought about what's actually happening inside your brain when you're suddenly ripped from a state of calm into a major crisis? I mean, 1 minute, you're fine, maybe even a little bored. And the next, your heart is pounding, your palms are sweating, and every single choice could be the one that matters? Today, we're diving deep into that exact switch, from boredom to terror, and what it tells us about how our minds work under extreme pressure.
You've probably heard this phrase before. For decades, it's been the go-to description for life in high-stakes jobs, especially in the military. And it just perfectly captures that bizarre reality, right? These long, quiet periods of just waiting, which are suddenly shattered by these short, intense bursts of action where literally everything is on the line. And look, this isn't just some old saying. It's a real daily struggle for leaders on the ground. This quote from an infantry officer really brings it home. It's about the human challenge of keeping your edge, of staying sharp during all that downtime, because you know that chaos could erupt at any second. It's a constant mental fight. So that brings us right to the big question for today. What is actually happening in our brains when we're forced to flip that switch from boredom mode to terror mode? Well, to get to the bottom of that, we've got to leave the battlefield and step into the lab. Okay, so how in the world do you study a brain switching from calm to chaos without, actually terrorizing somebody? To really understand this kind of mental whiplash, scientists had to get pretty creative to find a way to safely simulate that kind of intense stress. And that's exactly what a study led by Hein von Marley and his team set out to do. They wanted to use an fMRI scanner to peek inside the brain at the exact moment it gets hit with acute stress, just to see which systems get thrown into overdrive. So here's how they pulled it off. First, they deliberately stressed out one group of people by making them watch clips from a pretty disturbing and violent movie. The other group, the control group, just watched neutral, calm clips. Then, while they were in either a stressed or a calm state, both groups were shown images of faces that were morphing into different emotions, all while their brains were being scanned. So just imagine you're in that scanner. This is basically what you're seeing. A neutral face pops up, and then it quickly changes into a clear emotion. Sometimes it's something threatening, right? Like anger or fear. But other times, it's something totally harmless, like a happy, smiling face. The big question the scientists had was this: would the brains of the stressed-out people process these signals any differently than the calm group? And what they found, well, it revealed something absolutely fascinating. And honestly, a little bit scary about how our brain's threat detection system really works under pressure. It all comes down to this trade-off between two things: sensitivity and specificity. Let's use an analogy here. Think about the amygdala. That's a core part of your brain's emotional center. Think of it like a smoke alarm. Its whole job is to be super sensitive to any little sign of danger, right? To keep you safe. But what happens when you crank the sensitivity on that smoke alarm all the way up? And here you go. This is the proof. In the brains of the people who were stressed, this one area, the amygdala, it just lit up like a Christmas tree. It was totally hyperactive, fired up, and on the highest alert. Now, on the surface, that makes sense. Of course it's on high alert. But the real shocker wasn't that it was firing, it was what it was firing at. And this chart just lays it all out perfectly. First, let's look at the non-stressed brains, the control group. Their amygdalas was really specific. It reacted strongly to the angry and fearful faces, the potential threats, but it pretty much ignored the happy faces. It could tell the difference. But then you look at the stressed group, and it's a completely different story. Their amygdalas went absolutely nuts for everything. Fearful faces, angry faces, even the happy ones. It was all treated like a 5-alarm fire. The smoke alarm wasn't just going off for smoke anymore. It was screaming its head off for a piece of burnt toast. And there's actually a scientific name for this state: indiscriminate hypervigilance. What it means is, under serious stress, your brain doesn't just get better at spotting danger. It becomes super sensitive to all emotional signals, but it loses its ability to tell a real threat from something that's totally harmless. It basically sacrifices specificity for maximum sensitivity. So, what does this brain state actually mean for a soldier in a firefight or a first responder at a chaotic scene? How does this indiscriminate hypervigilance actually affect their ability to do their job when it matters most? Well, that brings us to something called the performance cliff. This discovery inside the brain helps explain a really puzzling thing that people in high-pressure jobs have seen for years, and it's all about the way people fail. We tend to think that as stress goes up, our performance just kind of gradually gets worse and worse. But that's not what the research shows.
According to what's called the extended U model, people can actually maintain a surprisingly high level of performance even as stress is building. They're operating on this stable plateau.
But right at the very edge of their capacity, something snaps. As you can see here, their performance doesn't just dip, it becomes wildly erratic and unstable right before it completely collapses. People don't just slide down a hill, they fall off a cliff. And that is the outward sign of a brain that's in total overdrive. A brain that just can't sort the important signals from the noise anymore.
Now, in the short term, this is a powerful survival tool, right? A brain that treats everything as a potential threat is way less likely to miss the one thing that could actually kill you. But what happens after the crisis is over and the brain can't seem to switch back to normal? What's the long-term echo of being in this state? And this is where this research becomes so incredibly important. Because this shift into indiscriminate hypervigilance doesn't just explain why people fail under pressure. It might just be one of the keys to understanding how psychological trauma, like PTSD, actually takes root in the brain. It's like we're looking at the neurological blueprint for how one terrible experience can rewire a person for years to come.
Just think it through. During a traumatic event, that intense stress shoves the amygdala into that hypersensitive, nonspecific state. So it starts making these powerful fear connections, not just to the real threat, but to all the harmless things that were around at the time. Sights, sounds, even smells. The fear becomes overgeneralized. And then, long after the event is over, that smoke alarm can get stuck on its highest setting, triggering this massive threat response to cues that aren't dangerous at all anymore.
And that leaves us with a really powerful final thought. What this research shows us is that the brain's response to terror isn't some kind of flaw. It's a deeply wired survival strategy. The real challenge, then, isn't just about getting through those moments of terror. It's about understanding the echo they leave behind. Because if stress can literally teach a brain to see danger everywhere, the real question becomes, how do we help a mind that's stuck in overdrive learn how to feel safe again?